Howdy, and welcome to my fourth video in this function series. In today's video, I'll be going over rational functions, specifically the definition of one, various properties such as domain, x-intercepts, y-intercepts, the end behavior, and finding asymptotes and holes. I'll also be going over combinations of functions, including addition, multiplying, dividing, and composing, so putting one function into another. These practice problems I'm about to do are from the Virtual Math Learning Center. A link to these problems will be put in the description. Alright, so question 1. So we're told to find the domain, the holes, vertical asymptotes, y-intercept, x-intercepts, the horizontal asymptote, and the graph. Okay, so the domain, right? This is your set of all valid input values. So for this function, right, it'll be the set of all valid x values. And when I mean valid, I mean when you plug in the input value, you should get a valid y value back. You should not yet, does not exist, or so some type of error along those lines. A hole happens when you have the same zero in the numerator and the denominator. So the factor appears twice. Even if they cancel each other out most of the time, it is still a discontinuity. But instead of being a vertical asymptote, which is much more jarring, right? It's just a hole. So you draw your graph, and then right at that x, you draw an open circle. Your vertical asymptote, this is where you get your zeros, only in the denominator. And this is in any denominator. It doesn't need to be the main fraction, right? If it appears in the denominator, it's going to be a discontinuity. Your y-intercept is when x equals 0. Your x-intercepts are when y equals 0. Your horizontal asymptotes, so this relies on looking at the leading terms, okay? So based on leading terms, on the numerator and the denominator, you have these abbreviations. So there is, actually let me use the space below. So sorry. Okay, so you have, let's do, so you have degree of the numerator, okay? You have degree of the denominator. If, so BOBO is the expression, or the acronym, sorry. This is bigger on bottom. Bigger on bottom, 0. So bigger on bottom means your order, right, the degree of the bottom is larger than the top. And that means your horizontal asymptote is y equals 0. Okay. Botna means bigger on top, no asymptote. So as it implies, your top is larger than the bottom, and your HA does not exist. And we have eats DC, This is exponents are the same. Divide coefficients. So when top equals bottom, your horizontal asymptote is based on leading coefficient on top over leading coefficient on bottom. Okay. Sometimes you hear the term slant asymptote, and slant asymptote is whenever your horizontal asymptote is linear. Okay. That's all like the fundamental stuff. And then using all this information, you'll make a graph. So our function is f of x equals 2x plus 5 for x plus 2. Okay. So first things first, right? We can just go in order, right? So for domain, right? Generally, the domain is from -infinity to infinity, but we need to check for some restrictions. One of them is the radical, right? If you have an even root radical, then the inside of the radical has to be non-negative, so 0 or positive is what we're looking for. If you have a logarithm with a positive base, then the argument must be positive, like strictly positive. So it can't be 0, can't be negative. And if you have a denominator somewhere, right, that denominator cannot be 0. It is the cases in which that denominator is 0 is where you find your vertical asymptotes and your holes. Okay. So first things first is we're going to look for for restrictions. Let me erase this. We're going to look for restrictions. The only restriction I see is this denominator, right? So x plus 2 cannot be 0. So x cannot be -2, right? Because going off this, right? Our domain is everything but 2. So we do -infinity to -2, exclusive union, -2, plus infinity. That's the first part of our answer. Okay. Now, with this factor, right, it is not in the numerator, which means we won't have a hole, as a hole requires for there to be the factor in both the numerator and the denominator. But since it's not a hole, it's going to be our vertical asymptote. And for a vertical line, right, that's an x equals. So whatever it has to be to equal 0. So x equals -2. And that's the second part of our answer, our discontinuities, right? For our y-intercept and x-intercepts, we just need to plug in 0, right? So for y-intercept, is when x equals 0. So f of 0 equals 2 times 0 plus 5 over 0 plus 2. This is 5 over 2. So our y-intercept as a point is 0, 5 halves. For the x-intercept, this is when our f of x is 0, and we solve for x. This is already fully factored, right? So all I'm going to look for is our numerator. So 2x plus 5 equals 0. 2x equals -5. X equals -5 halves. remember that in a fraction, when the numerator is 0, the whole value becomes 0. So you only need to look at the numerator. Our x value here is not restricted, so it is a valid point to use. So our x-intercept, and our only x-intercept in this case, is -5/2, comma 0. S here. You only have one y-intercept because that's how functions work, right? For x equals 0, you should only have one y value, so there's only one y-intercept. You actually have 0, but you'll never have more than one y-intercept. X-intercepts, though, you can have multiple, so just keep that in mind. Or you can also have none. Okay. Now for the horizontal asymptote. Right. If we look at the powers, right, we have 2x on top and x on the bottom. These are the same powers, right? So same powers, that means we use each DC. And we can use the coefficients of 2 and the implied one to get our HA of y equals 2 over 1, which is 2. So y equals 2. There you go. So I am done with domain, the whole vertical asymptote, y-intercept, x-intercepts, horizontal asymptote, and now we just need a graph. So I'm going to draw my graph. Okay. I know that, let's see. First, I'm going to draw like our critical points. Okay. So my y-intercept is at around here. I'm just going to eyeball it. Okay. Okay, let me do some marks. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5, 6. Okay, so from here, right, our x-intercept, or our y-intercept, sorry, is at 5/2. So right around here. Our x-intercept is -5/2. So right around here. We have a vertical asymptote at x equals -2. It's about right here. Okay, and note that y-intercepts, or vertical asymptotes, I don't think cannot be crossed. If I remember correctly, I think horizontal asymptotes may be crossed, but it's super rare if they ever do. Okay? Horizontal asymptote is y equals 2, so it's about right here. Okay, so we know that horizontal asymptotes generally don't ever cross them. You stay on the same side, and vertical asymptotes you cannot cross ever, right? So if I know I have a point right here, right, that means I have to stay on this upper region. Let me use a highlighter. I need to stay in this region, right, because it's on the same side of the vertical asymptote, so on the right side, and it's also on the same side of the horizontal asymptote, which is above. For my bottom one, right, to be on the same side of both asymptotes, I have to be on the left side of my my vertical asymptote, and I have to be below the horizontal asymptote. Right. So I know that my curve roughly needs to be in these regions. Now, you could plug in some points, but note that when you have asymptotes, the behavior of your curve trends towards. So it's going to be very close towards these asymptotes like this. Okay, so that'd be my top curve. My bottom curve would be pretty similar. Go kind of like that. Okay, you see how my curves are. I'm going to use a different color. It's a good color to use, red maybe. Yeah, okay. So you see how my curve is very close to the asymptotes. Right? We're not crossing, we're not really touching, right? You'll learn more about this with limits. I would assume in Calc 1 question mark, but at least for pre-cal, right? You don't really need to understand this concept of limits. You need to understand that just that your graph tends to get very close to these asymptotes, right? It's like a fence, right? If you have all this space, right, you want to take as much space you can without, running over the fence. And this would be my graph um, for question 1, just not as colorful. Okay, so for question 2, same thing. We need domain, hole, spherical asymptotes, y-intercept, x-intercepts, horizontal asymptote, and a graph. The first thing I'm going to do is actually want to factor. So let's tackle this top one first, okay? So 6x squared minus 17x, what's that, plus 5? Okay. Looking for two numbers that multiply to 30, 6 times 5, and add up to negative 17. This is negative 15 and negative 2. I'm going to rewrite this polynomial as, why did I do that? Let's do minus 2x and minus 15x. We can take out 2x here, get 3x minus 1. We can take out a negative 5 here, 3x minus 1. Common factor, take it out. Add in the rest, 2x minus 5. Okay, so that is our numerator. For our denominator, let me move this back actually. Okay, for our denominator, we do the same process, and we're going to factor. I'm looking for two numbers that multiply to negative 30 and give me negative 13 instead. Add up to negative 13. This is negative 15 and positive 2, so very close to the original. You have 6x squared equal to plus 2x minus 15x minus 5. Take out 2x from the left. I get 3x plus 1. Take a negative 5 from the right. Get 3x plus 1 again. Common factor, take it out. Add up the rest. And there you go. And now we can form our new function, or not new function, our factored form of the version of the function, sorry. 3x minus 1, 2x minus 5 over 3x plus 1, 2x minus 5. Okay. I'm going to leave it as it is. Right? I know I can cancel out these two terms, but remember, right, this is going to be very important. I need this factor for the discontinuities. Okay. So first, the domain, right? My two restrictions from here. My restrictions, I need to look at the denominator. I don't have a logarithm or a radical, so there's nothing to worry about that. So we look at the denominator, and I see 3x plus 1 cannot equal to 0. 3x cannot equal to negative 1. X cannot be negative 1/3. I also see 2x minus 5 cannot be 0. 2x cannot be 5. X cannot be 5 or 2. Now, this 3x plus 1, right, is by itself. There's no 3x plus 1 on top. So this is a vertical asymptote at x equals negative 1/3. Okay. But now for this one, the 2x minus 5, it appears top and bottom. This will be our hall at x equals 5 halves. And in fact, we'll have to solve for this. So we'll have to plug that in. And when we plug that in, right? So when we plug in the Hall, right, we have to use the most simplified version. And the most simplified version is g of x equals 3x minus 1 over 3x plus 1. We'll plug in the 5 halves. Because remember, if you use the original function, right, you get the 0 on the bottom and top, which is no good. So we get 3 times 5 halves minus, I'll do 2 over 2. Okay. And 3 times 5 halves plus 2 over 2. This is 15 halves plus 2 over 2 over 15 halves plus, oh, wait, sorry, it's a minus on top, isn't it? Yeah. Plus 2 over 2 on bottom. We get 17 halves over 15 halves. And you multiply top bottom by 2, you get, wait, hold up. 13 over 17. Okay. Multiply top and bottom by 2, you get 13 over 17. So my Hall is actually 5 halves, comma, 13, 17. Okay. Move it up there. Beautiful. Okay. So, with this in mind, let's start writing some of our answers. Our domain would not include these x values. So I'm going to move this over to the side of it. So it would be from negative infinity to negative 1/3. I need more space on my, let's bring this down. Okay. Union, negative 1/3, comma, at least 5 halves, right? Yep. 5 halves. Union, 5 halves, positive infinity. Our Hall is, it's at 5 halves, 13 over 17. And our vertical asymptote is at x equals negative 1/3. Okay. So that is the first part of our answer, or first few parts of our answer. So this is done, that's done, that's done. So we need our intercepts now. For y-intercept, I just need to plug in 0 for x. So g of 0 equals, and we can use the simplified version, right? But I'm actually going to use this version. It's faster, and you'll see why in a second. So 6 times 0 squared minus 17 times 0 plus 5 over 6 times 0 squared minus 13 times 0 minus 5. Yeah, so every term with x as a factor just becomes 0. So by using the original function, I get rid of this one, this one, this one. Actually, let me use red. I get rid of these 4 terms with the zeros, right? And I am just left with 5 over negative 5, which is negative 1. So my y-intercept is 0, comma, negative 1. For the x-intercept, so this is when g of x is 0, right? And this time I'll use my factored version to deal with it, right? So I'm going to use my simplified version, because if I include a 2x minus 5, right, this one, I mean, it's already a restriction, right, because it appears in the denominator, so I don't really care about that. I just care about using the simplified version. So anyways, numerator is all I care about, right, because to make a fraction 0, your numerator has to be 0. So 3x minus 1 equals 0, 3x equals 1, x equals 1/3. So my x-intercept will be 1/3, comma 0, and these will also be part of my answer. There you go. Oh, all right. Do vertical. So this is done. That's done. Now I need horizontal asymptote. So my H8. Okay. If you look at the leading terms, right, we have 6x squared, 6x squared. Again, this is another HDC situation. Same degree on top and bottom. So we just divide our coefficients. 6 over 6 is 1. So my horizontal asymptote is y equals 1. Okay. Now let's make the graph. Somewhat straight line. Somewhat straight line. So I'm gonna look at my values real quick, just make sure. I probably don't need that much. Okay. So 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. I like drawing my asymptotes first. So horizontal, y equals 1 is right here. Okay. My vertical asymptote is at negative 1/3. So it's somewhere around right here. Okay. I'm just eyeballing it. I'm not really going for perfection. Okay. Our y-intercept is at 0, -1. So it's right here. Our x-intercept is at 1/3 0. So right around here. And we have a hull at 5/2, 13 to 17. So it's a little close to 1, right? So 5/2 will be around right here. So let's put a hull like right there. Okay. A hull is like a circle. It's literally a hull. Okay, so circle, open circle right there. Now again, so I know this side, right? To get all 3 of these points, I need to be in this region, right? I need to be below my horizontal asymptote and to the right of my vertical asymptote. That's where all 3 of these points are, right? I don't want to cross this, right? Now, the thing is, now what region do I choose here, right? Generally speaking, you want to go diagonally across. Sorry, that's wrong. If you're curious which one to choose, right? You plug in a point. So we can plug in like -2, right? When I plug in -2, I get 3 -2 minus 1 over 3 -2 plus 1. This is -6 minus 1 over -6 plus 1. This is -7 over -5, which is 7 over 5. Okay. So -2, 7 over 5 is around, like right here. Okay. So now I have a point there, right? That means every other point has to be in that region as well. Because we don't want to cross any asymptotes, right? So this is the region my other curve will be in. I had to take back my statement about going across because sometimes it could be the same, side of the horizontal asymptote too. So it could be a little confusing. So I'm going to trace my graph to here. Should stay close, and to these asymptotes we made. Here we can play a little connect the dots. Nice. Draw through. Bingo. There you go. That is my graph for question 2. Okay. Question 3 just asks us for the intercepts, asymptotes, and hulls. So this means x and y. Just be aware of that. Okay. So first off, I'm going to factor. So our top part, x squared minus 11x plus 18. We're looking for two numbers that multiply to positive 18, add up to negative 11. This is negative 2 and negative 9. So rewrite our expression. We take an x out from the left, x minus 2. Take a 9 out from, well, negative 9 out from the right, x minus 2. Same factor, take it out, add in the rest. So that's x and a negative 9, and that's our factored numerator. Now for the bottom part, we have x squared minus 5x plus 6. I'm looking for two numbers that multiply to positive 6 but add up to negative 5. Those are negative 2 and negative 3. And we'll rewrite our expression. Taking an x from the left side. Taking an x out of the left side. Left of x minus 2. Take a negative 3 out from the right side. Left of x minus 2. Same factor, take it out. It's about 2. Put in the rest, right? And now we form our newly factored function. X minus 2, x minus 9 over x minus 2, x minus 3, which just simplify down to x minus 9 over x minus 3, but I do need to not forget about this restriction. Okay. This restriction leads to a Hall, right? Because it's on both top and bottom. My x value is 2, where x is 2. And we plug that into the function, right? We get 2 minus 9 over 2 minus 3, which is negative 7 over negative 1, which is just 7. So my Hall is at 2 comma 7. Okay. Our asymptote here is just a vertical asymptote. So I should prioritize, so x minus 2 equals 0, so x equals 2. Okay. So x minus 3 cannot be equal to 0, right? Actually, we're looking for the vertical asymptote, so we're going to set it equal to 0. And x equals 3. So vertical asymptote is at x equals 3. Okay. So our VA is x equals 3. Our Hall is at 2 comma 7. All right. Oh, and for asymptotes, I need VA and HA. So this is first part of our answer. Okay. Intercepts are pretty easy. So you plug in values as needed. So y-intercept. So this is when x is 0, right? So we'll use our simplified version. So f of 0 equals 0 minus 9 over 0 minus 3, which is negative 9 over negative 3, which is positive 3. So y-intercept is at 0 comma 3. There's another answer. For the x-intercept, we're solving for when f of x is 0. So 0 equals x minus 9 over x minus 3. Only care about the numerator, as the numerator is just a solution to make the fraction 0. Because again, when a numerator is 0, the whole thing is 0. X minus 9 equals 0, x equals 9. So x-intercept is 9 comma 0. There's our next answer. So we have the Hall and a VA and the HA. Oh, not the HA, sorry. and the x and y intercepts, right? Last thing we need now is a horizontal asymptote. We have x squared as a leading term on top, x squared as a leading term on bottom. We use each DC. Exponents are the same. Divide coefficients. Our coefficients will be 1, right? They're implied because it's not explicitly written out. So 1 over 1 equals 1. So our horizontal asymptote is y equals 1. Okay. And that is it for question 3, because that is everything here. Now we have these two functions, right? And we need to find the domain of the new function. So number 1 is f plus g of x. Okay. So f plus g means we just add. So for 1, f plus gx is f of x plus g of x, which is 3x squared plus 5 plus x plus 7. And I'll do parentheses. Actually, let me color code. That might be easier for you. Okay. We'll do blue for f of x, pink for g of x. So you have f of x plus g of x. And this gives us 3x squared plus 5 plus x plus 7, right? Now we combine the like terms and we get 3x squared plus x plus 12. Okay, so we add these together. There's no denominator, there's no radical of an even root, there's no logarithm of a positive base. Our domain here is just everything. Negative infinity to positive infinity, excluded because it's infinities, right? For number 2, fg of x. So this is f of x times g of x. So I'm going to do 3x squared plus 5 x plus 7, right? So you'll notice that you could say, oh, well, when we multiply these together, we won't have a fraction, and there's no radical still, and there's no logarithm, so we can just immediately say that, oh, the domain is also negative infinity to infinity, and you would be right. We're not going to create any restrictions for multiplying these like whole values, right? But for the sake of completion, I'm going to solve it anyways. 3x squared plus 21x squared plus 5x plus 35. That's neatly in order already. And from this, you can clearly see that there's no fractions, there's no radicals with even roots, and there's no logarithms with positive bases. 3 is f over g of x, which is just f of x over g of x. Okay. We get 3. We get 3x squared plus 5 over x plus 7. Now we have a denominator, right? So this becomes our new restriction. Oh, this becomes our restriction. So x plus 7 cannot be equal to 0. X cannot be negative 7. So our new domain becomes negative infinity to negative 7, exclusive, union, negative 7 exclusive, or excluded rather, to positive infinity. Now 4 is a composition, so f of g of x That means I'm going to use f as my parent function, and we're going to plug in g of x as the parameter, right? The argument, right? So we're going to have 3, okay? And every time I see x, I'm going to put in the formula for g of x. So that's an x, right? The x squared. So parentheses, g of x is x plus 7, right? And in blue squared, right? You see how this x, right, gets replaced with g of x? And then, oh, that's it, and plus 5. From here, we can FOIL. So 3 times x squared plus 14x plus 49. This is using that the a plus b squared rule, right? And we will add 5. FOIL, distribute the 3. Get 3x squared plus 42x plus, it's 150 minus 3. So that should be 147 plus 5. And that simplifies down to 3x squared plus 42x plus 152. No denominators, no radicals of even roots, no logarithms with positive bases. So our domain will just be everything. So it'll be from negative infinity excluded to positive infinity excluded. Okay, and that is it for question 4. And with that, that concludes my video for part 4 of the series. Thank you for watching and listening.